It should preview up here in just a second. All right, there we go.
Mm-hmm.
I think we're live now. There we go. Have to do our little Optimus hands. So there we go. So hearts to everybody. We, of course, will show what that is all about later on. But so welcome everybody to a live stream. We're going to make an attempt at this. This will be interesting. This is Dr. Scott Walter, obviously, who's been with me many times before. So you're awesome. And by the way, also was the inspiration for this t-shirt, which we both have on. So you can get this at the merch store. So definitely check it out. I'm on an ego trip. So yeah, for anybody who knows, you know, the full self-driving with the Tesla, it's called the ego car. So we figured, why not do the ego trip? Yep. And Andre Carpathy or anybody from Tesla, if you're watching, just DM me and I will definitely shoot you a free one of those shirts because I thought that'd be pretty fun. You guys would enjoy that. The other thing we both have, because we're the Bobbsey twins apparently, is we also both have our Gigatech.
Yeah, somewhere around here. Somewhere.
That's all right.
Well,
I'll hold off for just 1 second. Because there we go.
Yeah.
Don't mess with Tesla.
And the other thing is we were able to get it without needing Doge.
That was the big thing. So, at the shareholders meeting. The advantages of being at the shareholders meeting, you can buy stuff with US dollars as opposed to Dogecoin. Anyway, if people in the comments will let me know if you can hear us, that would be awesome because that's usually an issue. So I haven't heard anybody say no yet. So, oh right, he's going to change his shirt because we now have...
quick costume change here.
Quick change.
So more appropriate T-shirt. Here we go. Whoops, somewhere in here.
Exactly. Let me see if. Let me make sure.
And
comments.
We love robots in there somewhere. Okay.
Let me just ask. Oh, Judy Campbell says yes, they can hear us. So thank you all so much for joining us. Hopefully there will be people who will arrive. So here, oh, good, excellent, good quality even. So this is a new version of OBS software on a new computer. So I just wanted to make sure it was all working properly. So anyway, the plan at this point is for Scott and I to talk through the picture and you of course have simulations and everything. There's links to all of this stuff in the description, by the way, because Scott is an incredibly generous person. So you can download a lot of this stuff and play with it yourself. But we're going to talk through the picture for, 20 minutes, a half hour or so. And then we're going to open it up to questions from the audience. So I'm looking at the comment section. So hopefully, we'll get some good ones. If you really want to support it, you can obviously do super chats. All that kind of stuff is awesome, but don't feel the need to if you don't want to. But anyway, so yeah, let's just start right off and show the original picture from Tesla's AI Day. This popped up when Elon was giving his talk at the shareholders meeting. So this was exactly 1 week ago, which is really weird. Now that I just realized that was exactly 1 week ago.
Exactly 1 week ago, and I'm assuming everyone can see this.
I think so. Hold on. The live stream is always delayed when I look at it over here, but I'll check. Yes, they can see it. Good. Okay. So cool.
So this is the image that made a bunch of fuss. And just give a little bit of background about the image before we really deep dive into it is, yes, it was exactly 1 week ago today that the shareholders meeting was held. And if there's actually a bunch of know-it-alls sitting in the second row here, which you can try to identify.
Yeah, if you look down at the bottom, you can see
making the heart.
Yes, making the heart. I was making the heart. So there you go.
And the other know-it-all is like wishing he was wearing a baseball cap at the time. Okay, so we'll just leave it at that. So that's about where we were, and this was pretty much our vantage point when that slide came up.
Right.
Something like that.
Right.
And of course, this is what people at home were seeing. They were seeing that. Where do you think our eyes were? They were not necessarily on the slide, and the slide was up for a brief amount of time. And so we didn't really look at it too closely, and it just looked like kind of a nice graphic. And then let me see. Oh, and of course, the other thing about it is that this is a picture of what the Optimus hand is supposed to look like.
Right.
So again, it's like a radical difference between the two. So it wasn't really clear right away that that could be the Optimus hand, at least to us. It didn't register. We were looking at a bunch of other things.
Right.
And then it was around.
Even now, of course, we're all speculating about this. I mean, there's a reasonable chance that it's just a graphic designer just airbrush some stuff.
Right. It's a reasonable chance. And of course, we'll get to which camp I was in. Because a little after midnight, John forwarded this tweet to me from Conculize that was showing the slide. Now, I didn't remember there being a pink slide there. And of course, if you read very closely, a slightly enhanced version of the slide reveals details maybe overlooked. And it did enhance some things, but at the same time, it made it look more like a Hallmark card. And I wasn't quite sure if that was legit or if it was just graphic art or not. Right. And, the next part of his tweet was, we can also see that the hands can change angle, unlike predicted by the engineer recently in Dr. Know-It-All, who suggested it would be static. The engineer, that would be me. And so suddenly I was like, whoa, wait a minute. Okay, so I kind of read it a little bit closer. That's why it got sent off to see what was being suggested. And of course, I couldn't resist jumping in myself. And my first thing was my snarky remark is like, you gleaned all that from one slide. That was not mocking him. That was mocking me. Because if you recall, we took this slide and turned it into a 2-hour video.
Right.
Right. So
we're going to try to keep things compressed and do all of this in half an hour today.
Yes,
so that'll be a major accomplishment.
So basically based on that and the fact that I did not have my laptop when I was just looking at my mobile app, I was not actually sure it was the actual hand, and I just thought it was probably DALL-E generated, which maybe other people thought that. And because I wasn't looking at the things right, I get a lot of the angles of the arms right, the motions of the range motions all kind of look wrong at first to me. And then, of course, that thumb looks a bit funky. When you get back here, there's just something weird about the thumb. And we're not going to focus on the fingers because that's a video on itself. All we know is that this whole thing is turning our heads inside out because we cannot figure out what the perspective is and where the solid parts are. It looks to me like a lot of the mechanics have been redacted. And that's why things just don't look right. And things look like hinges, but they're not really hinges and all these other things. So those were kind of my points. And then when I finally got home, I was going to say, well, I'm going to kind of put something out there and say that we should have a follow-up video on this. Kind of looking at the technical details. I'm just going to jump through these a little bit quick because later that day, Rob Maurer kind of mentioned this in his video that a lot of people thought there were some hidden details in there. And then John Kreider also came up and sort of also said that there's a possibility there's some breadcrumbs in there. And she makes a pretty good argument because there's always breadcrumbs. I mean, every time there's something out there, there is some information.
I think the last one that had the dojo computer I think that was the AI Day Part 1, and that was an exploded view with an awful lot of information.
And even Battery Day, I mean, no one could really figure out what the Battery Day thing was. So there was something kind of going on there as well.
Right.
Okay, so
I think one thing that's really interesting to notice here, just from the beginning, if you back up one slide to the big picture again. So yeah. The big picture in my hand.
The big picture.
There we go. Yep. Any of those will work. But it's really interesting because if you look at this, it's very difficult to tell if this is palms out, in other words, looking at it like this, or whether you're looking at it like this.
Yeah, whatever.
Whether it's palms out or palms in. So it's really interesting that if this is a real picture, I do think there's a lot of stuff that's been sort of airbrushed out.
Yes.
There's details that seem to be missing.
And as you can see, is that when that goes in there, whatever sort of enhancement was done there, that kind of threw us off because we couldn't tell if these were shadows over here or if that was actually part of the box. Right. And you can imagine our state after midnight in Austin. So so then I tweeted this out. And I had written, a more exhaustive kind of thing, just saying, doubling down, kind of saying, oh, it's not real, it's fictional. And then I actually looked at the real picture in higher resolution and a bit more closely, and I realized, I'm not so sure now that it's fake. It's possible it could be real, but I still decided, YOLO. I'll say I think it's fictional, but let's say I wasn't so strongly convinced, and that at least I'm wrong. We'll find out something about it.
Right.
And then, further days, and I realized what I should try to do is a simulation of it. So then I followed that up, pretty much the feeling was, let's take a closer look at what's going on. So again, here's the image. What are we seeing? We're going to focus in on the wrist mechanism itself. Right. So there's the overview, and we're now concentrating on this part here.
Right. And the basic idea is this just a graphic design, or is this something that could actually work? I
Right,
think that's
right,
the
right.
basic question. So,
And the thing that's hard to tell, if you go back to the original image, you're looking here and you're trying to figure out where are all the joints. You can kind of see where the fingers might articulate. The thumb is really weird. We don't know what's going on. And we're looking down here. I'm trying to figure out what's the wrist doing. Where does the wrist actually articulate? At first I was kind of thrown off by something down here, thinking that maybe it's something down here, and realized no, it's really in there. And so when we blow it up and look a little bit closer, this is what I think is going on. Is that you have this articulation, which I was calling the pitch. That's the hand going up and down like this. And then it looks like this red line here that I put in there, that is probably the yaw. That's the one going back and forth. That's the one I thought would not exist because it's barely used and you may not need it. And again, I mean, kind of going back to my original argument of why it wasn't there, I guess I have to defend myself a little bit, is the original AI or AI one day was that there's going to be 12 servos or actuators for the arms, which means 6 each. And I've looked at this, I don't know how many times, and I'm absolutely convinced there's 3 up here in the shoulder. There's definitely 3 up here in the shoulder. I've looked again and again and again. And 1 in the elbow, that means we're at 4. There's only 2 left. So there can only be 2 in the wrist. So something happened between then and now. They decided to change it. And I think I have an idea what happened, but I'll leave that to the end. Okay. So.
By the way, we have a vote for palms out.
Okay, it could be.
Geo30, really Geo5 says palms out. So.
It looks to me like, MC Escher came up with that drawing somehow. He was involved in the perspective of that. Nothing fits. Nothing works. Okay, so if we look at this, what we're seeing is that probably articulation here, which is the pitch. This is that yaw, which is that little bit.
Right.
And what's actuating it are what looks to be these 2 sort of piston and rod mechanisms here that push in and out, and you'll see what looks like a really funny kind of joint here. And what that joint is basically a spherical joint.
Right.
And the idea is it allows 2 degrees of freedom, 2 degrees of motion. So it's not a pin joint, it has to get a little bit. And it has a primary axis where it can rotate a lot, and a secondary axis where you may be limited a little bit, but that's okay. It's not gonna be a problem. And it might look something like this. I mean, it's not exactly like it, but you can find things like this on Amazon, which is exactly what I did here. As I was able to find.
Right, but the basic idea, as the pistons pull, the joint that it's actually attached to has got to rotate also.
Yes, yeah, and we're going to see that when you get into it in the reality of what's going on when you get into the math.
Right.
And then, there are other mechanisms, like this is an example of a Delta robot that uses something a little bit different. It's a ball and socket kind of thing that allows you to get 2 degrees of freedom, but, it's some kind of extended bar mechanism like that would move it along there. It's not exactly the same, but the similar idea. Okay, so then finally I went from, and probably no one understands this tweet at all. You have to be a certain age to understand the Miller Lite reference here. I'm assuming Rob Mauer would. He is from Milwaukee, but if you remember back in the 70s or 80s, the argument about whether it tastes great or is less filling. So I was kind of saying that I was in the taste great camp, and now I've moved over to the less filling, meaning it's probably real. And you have to be a Pythonist to understand why I use the single quotes. Basically, I air quote with single digits. I don't do this. I'm a Pythonist.
This is how you know a Pythonist as opposed to a normal person. As opposed to quotes, it's quotes.
Right. And which line does the Pythonist take at customs?
Oh, gosh.
Nothing to declare.
Oh gosh. Oh.
Okay.
My business partner, if he happens to be watching this, is going to find it hysterical.
The number of viewers just went down like that. You probably just saw.
I'll watch the stats. It'll just go like.
Yeah, watch the stats, everything. So pretty much in here, I linked to, whoops, if I can get back there, to a little video that shows how the mechanism works. And what I'll do is maybe, do you want to see how the mechanism works, or do we want to jump to the math of it first?
Oh, no. Let's watch it move. I think people will appreciate it.
Okay, so
and by the way, this stuff is all what's in the description. So if you go, you can download the file, the viewer, all of that stuff. So
this is a simple little movie that I made that I downloaded onto to YouTube. You can find it. It's about a minute long. And then there's also a 3D viewer, which we'll talk about a little bit later, that you can download. It's going to be on your phone that you'll be able to do. We'll get in that a little bit. But you can see a little bit about what the mechanism does here. And I'll just run that again. And you can see this is the pitching motion, how it's able to do the pitching motion. And that's how it's able to do the yawing motion. just by having the differential movement on those two different pistons, you're able to get the yawing, and if they are coordinated, you get the pitching motion.
Right, exactly.
Okay. So now,
by the way,
this is
Daryl,
my
I just tried to
cue.
turn up my volume, so hopefully it's up to equal to,
Okay.
to John's. Scott
So
said
this is my cue to try to jump to another tab here, or to my actual simulation right here. Okay. So here's where I was able to simulation, so we can start to look at this actually in 3 dimensions. And what I'm going to do is I'm just going to jump to one of these, an orthographic view right now, so we can sort of see what's going on. And we know we have an axis of rotation here, and we have this piston and rod mechanism, and what looks like some pin joints there. And the way to analyze it is to basically overlay a triangle on that. And the red and the green links do not change. Those are fixed. They do not move. And you can see there's going to be rotation about where the white dots are. And if you look at that thing, you would say, okay, so we want to make the hand go up and down, which means we need to somehow change the angle between the red and the green. And that's done just by extending the length of the blue. Okay. And when you do that, you see that angle changes. That gets you exactly what you want. But there's a consequence of moving that angle there. And remember, the sum of the angles has to be 180 degrees. If I change this angle here, that means the other 2 angles have to change. And you have to calculate those things. And you can actually calculate them very easily using something called the law of cosines. And the law of cosines is the general form of the Pythagorean theorem. As a matter of fact, the Pythagorean theorem is the degenerate case when the law of cosines is at 90 degrees. So it's a very simple rule or law that goes along here that allows you to figure out how it moves. And what that tells you is that, well, when you build this kind of mechanism, not only do you have to have it rotate there, but you've got to make something that rotates here and something that will allow it to rotate there. Otherwise, it just won't work. I mean, that's why it's called the law of cosines. If you don't obey it, it's just not going to work. Okay, it's very easy to do that in the 2D case. But then when we start to add the other element to it, it gets a little bit trickier on being able to do this, because now when we add the yaw into it, it's no longer a 2D problem, it's now a 3D problem. Right. And you see the triangle kind of falls apart when you go ahead and do that. And it just requires a little bit of math to figure this thing out. Now, in our previous video, we talked about forward kinematics and inverse kinematics. And I said forward kinematics is easy, it's like arithmetic, whereas inverse kinematics is very complicated, and that's where the real math happens. It turns out in this case, it's the opposite. The forward kinematics is very difficult to do. The inverse is super easy. And that's because what I didn't say in the first video is that rule applies to serial link mechanisms. Right. In other words, mechanisms that are chained together. This is a parallel kinematic mechanism.
Just to put that into perspective, that'd be shoulder, elbow, wrist. That would be a serial mechanism.
Right,
so, yeah.
Exactly. So here we go. We have this thing, and it's a little bit tricky to get it together, but we can get it to articulate. And of course, the first thing everyone kind of wonders, so how do you roll the wrist? You know, how is that being managed? Like, well, it's very simple. It just, you know, rotates about here. That's it. Right. Doesn't do anything other than that. And then if we want to be able to do the yaw, you see we can yaw back and forth this way, and then we can go ahead and then by extending these things forward, we can get that pitching motion very easily. And we can see when we do this, when we go to the top, that when we go to the yaw, it's introducing some weird things here. So we have to have a spherical joint everywhere. Right. We have no choice. In order for that to work and to stay together and be mechanically sound, you have to do that. Right. You have absolutely no choice.
So Mark Plott just threw up a question, which we actually talked about yesterday when we were discussing this, which was why, you know, I think what he's talking about, he says no pistons or pulleys, but basically the idea of hydraulics and things. But we want to get into that. Can be driven by anything. They don't have to be driven by hydraulics or pneumatics.
Right, or anything. Right. So, Now, that is something we want to touch on. Do you want to touch on that right now, or do you want to defer that? Because we were, that was the question I threw out to you yesterday. I said, okay, John, how is that actuated? You know, what's going to make that thing go back and forth?
I mean, you know, the 3 obvious things are hydraulics, which is fluids, pneumatics, which is air, or some sort of gearing system, which would use some
sort of ball screw drive where you have some sort of motor that's spinning inside of there. Now, these proportions are not quite right. If we go back to the original drawing, that cylinder looks really big and beefy, and I'm not quite sure why it has the dimensions it does. So this was really rough just to show schematically how this mechanism works.
Right.
Okay. I'm pretty sure it's not hydraulics. Now, it does look an awful lot like a forklift. or not a forklift, a backhoe
Yeah.
or front loader or anything like that, which you're used to seeing that. The thing about hydraulics, they can deliver a lot of power and a lot of force very easily. And you just have one motor that's pretty much building the pressure. All you need is a bunch of valves to be able to control it.
Right.
That could be one way of doing it. But the problem with hydraulics is they're really leaky. It's very hard to make the seals that won't always leak. And the other thing is they really are too powerful. And remember, you're supposed to be able to overpower Optimus, not the other way around. So you probably wouldn't want to do that. And the other thing is,
you don't want Optimus to just come up and go like, "Hi, how are you, Squish?"
Yeah. Yes,
like,
yes.
Oh,
and then recall that the grid fins on, I think of the Falcon 9 are hydraulically controlled. But for Starship, they're going to be actuated by the motor. So even SpaceX is like, well, the hydraulics, they're all very nice, but we're not going to use them in the future because they just have too many issues. Or we think it's just better to go ahead and have them actuated with servo motors. So I don't think so. However, pneumatics is kind of somewhere in between. Even if they leak, who cares? It's just air.
Right.
And you can store a lot of power in like a small scuba tank.
Right.
And this would be like the most steampunk thing if it was. I mean, you'd be going on constant back and forth doing this. And so, hey, maybe it would be. So hydraulics, I give zero chance of that.
Right. I feel like pneumatics has no chance because it's just too loud.
I won't rule it out. But see, I've already been proven wrong regarding the yaw. So I have to hedge my bets here and put it out there that it's a possibility. If it turns out to be true, you heard it here first.
Right.
But I'm going to say it's probably not.
It would be pretty annoying to work around a robot that was going all the time. So
yeah. But again, could be kind of cool, and it would be possible. But the thing about it, they're very hard to control because it's more of an on and off. It's something you typically use in a clamping mechanism. You just want to open or close. And if you want to get something in between, it's very hard to control that. However, it's really good for force control.
Right.
So depending on what they want to do, I wouldn't rule it out. I mean, you get some pretty bright control engineers between the two organizations.
Right.
They may have solved a few problems, but I don't think so. I rule it now.
That would be interesting. So just as an FYI, Mars Embassy said, what about memory metal or other options besides like just screw drives and things? I don't know. I don't know enough about that to really be able to give a reasonable
memory
answer
metal.
To that.
Wasn't that Terminator 2?
I think that was mimetic alloys. So let's please not turn this into it's
He's
already
trolling you, John.
It's already turning more silver. So it was white and clean. Now it's turning silver. So we're already turning into the Terminator. So there you go.
Right. Okay. Now, what I'm quickly going to do here is that I'm showing you basically the same thing right now, but you notice the application is a little bit different. What you saw before is the authoring tool that allowed me to build something. This is actually a playback, and as you can see, it's not a movie. It's actually an animation that you can go through and view.
Right.
And this is using a viewer called Visual Components Experience, which is free that you can download online. Again. And I can even show it on my phone, not just here on the screen. Go ahead and remember to bring it up. Okay, so here is my phone right now. We can see that. So there it is on there, and you can move it around and have all kinds of fun with it. So if you actually want to look at this thing in 3D and play with it, and you can even do this in VR if you download the Windows version of the application.
Right.
And that I will kind of show in just a second here, if I get the right screen up here. You can find it under Google Play in the App Store.
Right. And like I said, I've got all the links are in the description, so you can just
the links are in there, so you can go there and get it. And if you want to do the virtual reality, then you just go directly to our website.
Okay, so Mars Embassy and some others were talking about this. Is that the memory metal actually is something that changes? It's more like a muscle where you apply an electrical voltage across it. It contracts, I believe. So that is. But
again, I kind of wonder, is it kind of like an open closed state, or is it something you can control in between?
Again, I'm
not sure if you get the fine control.
Well, the other thing you have to remember is not just the wrist, but also the fingers, right? Because there's an awful lot of stuff that has to go on in the fingers, and having memory.
We're going to stay away from that.
Possibilities. I'm going to touch on the fingers. I want to talk about those briefly, but anyway.
Yeah. So this you're going to see in the description of all the possible links, and that basically is a logo you want to look for to make sure you get the right app and you can download it. What will also be in there is a link to a Google Drive for a 56 kilobyte That's kilobyte, not megabyte, kilobyte file, which is the file that we're looking at to be able to look at. So
Right.
it's very crude. It's very easy. You can show your friends on the phone and everything else, and then find out whether they're right or wrong. Okay, so getting back to, just to kind of remind us of what the original technical details look like, because what I'm now going to do is we're talking about, is it pneumatic, is it servo controlled, stuff like that. I think I know the answer. Okay, yes, I've been holding this back, John. Okay,
there we go.
I again looked at this very closely last night because I really wanted to convince myself that there were 3 axes up there. I was thinking there must be something I missed. There had to be something I missed. So I was really looking very closely at the mechanism. And as I started to look closely at the mechanism, there was like, oh my gosh, I think I just solved it.
Right.
There's some funky things going on around here. I mean, okay, here's the shoulder. We can see the yoke for that, the second axis.
Right.
We can see where this goes in here. And I was always wondering, what's this funky little thing here?
Yeah.
We see
is the
another one of them
interesting
over
question.
here.
Right.
And it always kind of bothered me, and everything kind of looked like an X-ray. I'm going to focus in right now on this part. Okay, look a little bit closer. Do you see something going from here to there? We're going to make it a little bit bigger. It's out of focus. But if you can't see it,
yeah,
what we have
do we have a radius and an ulna?
What we have is a connecting. We have a connecting rod that goes from here to there, and another connecting rod that goes from here. It was hiding in plain sight the whole time.
Interesting.
How that wrist is going to work was right on in there, and you've got 2 different probably actuators here. It's not pneumatic.
Right.
I think we can rule that out now. It's not hydraulic. They're probably motor driven. And it kind of works a little bit like, the steam engine trains and stuff like that, how those mechanisms are going on there.
Right.
It's going to be very similar. What I'm wondering is whether they were thinking about yawing all along, because you can get away with just 1 in here, but we can see there's 2.
Right.
But they may have put 2 in there just to avoid any sort of binding situation, that if you have both of them on there, you can kind of make sure the mechanism goes through it. Because if you're pushing on one side, sometimes the mechanics will bind. And it may have been along the way, someone said, hey, wait a minute, we could maybe do a little bit of yaw if we make this differential.
But also, do you think that the reason why it's now outside of the wrist is because they needed more torque to be able to?
I don't think it's outside the wrist. I think it's just we're seeing more detail that's there. It's probably covered
I'm saying
somehow.
in the render.
Yeah.
Or are you saying that's going to be covered?
Oh, in the render. I think it's all going to be covered up. Basically, they've probably taken off the exoskeleton or whatever is there. So it may somehow be in there.
This truly is the Terminator.
Yeah.
If we just put some nice skin on top of it, it's going to be terrifying.
Yeah. So there's going to be something around there. Right. And so then, now remember when we were going back here yesterday, we were talking about, it's like, well, does this go all the way back there? And I was like, nah, you wouldn't make it. Why would you make the pin joint go all the way back? There's absolutely no point.
Right.
Extra distance and stuff like that. And then sure enough, once I do a prediction like that, it's completely wrong, because now this is indicating that you can sort of see that right about here is right about there, I think, is where the forearm rotates.
Right.
So it's not split in the middle. It's like this whole piece here rotates, and and the elbow is back about there. So you have a small chunk here, which is the elbow, and that whole forearm is then rotating through there.
Exactly.
Okay, so we got that. Now, I was
you got
other things.
Geo30, Geo5 gave you a great find for the little the shadow stuff that's inside that original image.
Yeah. Now, the other thing I was wondering is whether the elbow would do the similar thing, because we know C3PO has something like that for the elbow joint. Do you put an actuator in there? Normally, you want to put an actuator right in there, but there is historical precedence that the early days of building the robots, the servos were not compact enough to be able to actually fit directly into the joints. So they use these ball screw mechanisms here to actually move these things. So there is no motor here. That is just basically a follower joint right there.
Right.
And it's as a result of the extension of this and that. So it's a very similar thing. So you could be doing that. And again, if we go back into here, I'm seeing the same kind of weird mechanism here and something that almost looks like a connecting rod. I wonder if the elbow is also being done the same way.
Right.
The elbow might be powered back here, because something looks weird about this. And also that looks like a joint, but that joint doesn't look right where the elbow is. So that might be where the connecting rod connects together to the tie that's going to allow it to articulate around there. There's something strange about all that's going on in there. So now let's go back to the simulation. So I discovered this last night, and I still do have a day job. So I'm trying to go back into here to figure out what that thing looks like. And so here we go. This is my new version. All right.
Oh, I like this. Okay, so you've actually tried to model it out a little more closely.
Yes.
To the,
So
yeah.
what ends up happening here is that you've got this thing rotating around. So let me
it's a
kind of get
double
it. So
wheel.
that thing rotates there. That's a very simple, that's a very common mechanism.
Right.
It's basically a 4-bar mechanism, or sometimes referred to as a parallelogram type of mechanism. You can't quite see the parallelogram in there, but there is just a node here, a node there, another one here, another one here. And if these links are all the same as a parallelogram, if they're different, then it's just a 4-bar mechanism.
Right.
But it works that way, and then you can get this to work. Now, what's really interesting, I only solved the 2D problem. I've only got halfway through my solution because, like I said, I didn't have time to finish it off right.
Right.
And I thought this whole thing was going to fall apart. And you'll notice for the little bit of yawing we have, which is about what the human hand does,
Right.
you could be fooled into thinking that thing's staying together. Now you can see when I do this, my math is falling apart.
Yeah.
I did not get it right.
Right.
But for a very short range, it's working pretty well. And
Which
look,
may
that
be all they
stays
really need to
pretty
be able to
parallel.
do. Yeah.
Yeah, it stays way more parallel. I was expecting the angles to be all over the place, and it looks like, it might actually be able to do it without anything funky or weird in there.
Right.
In these different positions. So that is probably closer to the way the mechanism works. That's what I think. And this is what I was holding back from you, John, all day. All right.
You did tell me there was something coming up. So that is very cool. So I love that you went back, because I kind of just assumed that the original was just trash. I was like, that was last year. They don't, but you're saying like, no, they could actually do this. Yeah. There still is the matter of that big box that's on top of the wrist in the new image.
Yeah, so, that we're having a hard time.
Well, that actually, I personally think that has to do with the fingers, because you still have to control the fingers, and you can't control the fingers like directly because it just takes up too much bulk.
The other point I wanted to bring out is this idea of a 4-bar mechanism is also very common in robots.
Right.
Is right here, the actuator for this is actually down around here, and it moves this lever here, which moves this thing, which makes that thing go up and down, and again here. So, and that's very similar to what we're seeing in there, except far more compact, way more compact. This is usually done for robots that need to have extremely high payload. So they will do something like that. And then again, I was like the close up here, whoops. I'm sort of wondering what's going on there. What could be that possibility?
Right.
Yeah, let me quickly go back to the slide that we were originally looking at here, and that is going too fast.
There we go.
Where is it? There. Okay, so let's go back to the original slide. We're talking about this thing here. What is that?
Yeah, that's the thing that's interesting. So,
and again, looking at these things, I mean, this is interesting in that there seems to be something inside of a sleeve here inside of something else.
Right.
So it almost looks telescoping. So I almost wonder, well, maybe I am wrong, and it doesn't go all the way back there, and they've put something in here, and that's the full servo control right there. That could be very different.
Right.
When I tried matching this perspective with what I had put together, I could not get the perspective to kind of match with this, because you see how these are kind of diverging. When I try getting the same thing, they actually converge together. And that just seemed weird to me. It's like, why can't I get these rods to go in the same way? So if this really is a render of some sort, then I would think I would be able to match that. So there's some other things going on that's hard to tell, because everything back here is hidden. We cannot see it.
Right.
But that's rather interesting. And then this thing, why is it there? It's just it's just in the way.
Yeah. It's a big extra bit of bulk. But so a distributed battery, Dusty, that he asked that question. We definitely, I've talked about that one before, about the possibility of distributing batteries all through the body.
Yeah, but why there? Why there? I mean, it's like, okay, I've got my watch on here, but I know whenever I do any work, this watch gets in the way.
Bash. Yeah.
It's just going to get in the way. You want to get it. Now, something that's interesting, if you take your wrist, I get like 2 knuckle bones right about there.
Right.
That look an awful lot like these 2 guys.
Right.
Which makes me wonder if I'm Optimus, and I just don't know it. I got it. I got the spit tank finally.
Jeez.
All right.
We're finally, see what's happening is Elon is actually developing the simulation that we're all in while we're watching.
Yeah,
So
yeah. Well, maybe that's what's going on. So it
steam
seems rather
tank.
interesting that you do have something, some protuberance there that when it
Right.
gets covered up will be very much like you almost have in your wrist already. So
Right.
it is very natural. And rather than using tendons, you're using this push-pull mechanism, which is
Right.
a much better way, but you get kind of that tendon control. And now,
I,
one of the drawbacks of this mechanism, can you think of what some of the drawbacks are?
well, I mean, it's bulky for one thing, but
Yeah, I think that the first thing was like one of my conclusions here, if I get that up from the current slide, boom, right there is, the mechanism is sloppy.
yeah,
Right?
yeah.
There's no doubt about it. The reason why they like to have the servos directly on the axis is that you have much better control of the axis, and
Oh,
there's absolutely no slop. So there's where you were driving it is where everything is being actuated, and you can measure it there very easily.
right.
So this mechanism is sloppy. You've got 12 moving parts to accomplish basically 2 degrees of freedom.
Right. By the
So
way,
each
Tronicum actually suggested perhaps it's a local AI board, which would be really interesting. Distributed processing, you've actually got a processor hanging out right over the
Sure,
wrist. That
sure,
would be
sure.
really cool.
So the result of this is like reduced precision when you make a mechanism like that. You just every time you add a degree of freedom, you're just asking for more things. You've also got the fact that you're going to have deflection in those arms. Now you can make them very stiff, or those tie rods that are going along there, they're going to deflect and do everything else. Direct drive is much better for accurate applications, which is typically what industrial robots do.
Right.
But the thing is, industrial robots are really dumb, which is why we have to build them to be so exacting and so precise to make sure that they are repetitive and can do the same job again and again and again.
Right.
But they have no vision. Yes, there are systems that are set up vision, but for the most part, they are driving blind. They just go back. They're assuming the parts where it's supposed to be.
Right.
So when you start coming in with something that has vision, the question is, does it matter? Because look at our wrist. Our wrist is probably one of the worst designed mechanisms. I mean, it's just, if you were trying to design a wrist, you wouldn't design it this way. Yet it works. It tends to work. And it works because we compensate with software.
Right.
Yeah. Now, I'm sure there's going to be a lot of biomechanicists out there saying, what do you mean? It's like, it's really elegant. It's a lot of, I'm sure there probably is a lot of beauty to it, so,
Right.
But it is a rather interesting kind of mechanism
Right.
that is able to somehow accomplish
It's
a
certainly
lot
not
of precision
exact.
in a way.
The
Exactly.
the precision comes from the match of up here with down here.
Yes,
So,
it's coming from that.
So-
So it may be that they came up with that because the problem with putting an actuator in there, you've got 2 degrees of freedom you have to go in there. How am I going to stuff those motors in there and get the torque that I need?
Right. Right.
And then I've got services and other things. Don't forget the fingers are still out there. So how are we getting all the cabling that might be needed for that to go through there, or the power and everything else? So you've got a very skinny wrist. And I think that's also a problem in the human hand. That's the reason why our arteries expose there.
Yeah.
Normally they're supposed to go internal, but this is like
Right.
one of those few places that it gets exposed. It's like, there was nowhere else to route it.
Exactly.
It's really hard. Nature couldn't come up with a great solution either
Right.
on that. And so, the engineers are kind of faced with the same problem. You've got the joints that are getting in the way. How do we get all our services through? And so the idea of bringing all that back, and especially if you want to bring the motor way back here with that long extension that we're talking about, rather than having it up close. But it looks like they are doing something weird. To me, it almost looks like it's one of those things that Spider-Man would have, right? To be able to shoot the webs out or something like that, or maybe it's lasers. We just don't know about it, but it looks.
I mean, my personal opinion is it has to do with the fingers more than the wrist, because I think you've got to have some. I mean, if you're going to do it, I love the idea of memory metal for the fingers. That's cool, but if you're going to do it with cables, someplace you have to have the little things that wind the cables up and back down again. So you've got to have room for all of that stuff. So, can you go back to the picture, the original, like the AI Day, like slide?
The very first picture.
Yeah.
Let's get all the way. I know it's all the way at the beginning. There,
one of the
right there.
No, that one right there. Okay, so I think it's at least worth pointing out here that the fingers are not normal human fingers that we've got. So there's one we're debating. Scott and I have been debating for quite a while how many fingers are actually on the hand. there might only be 2 fingers up there and a thumb. So it is possible that he might he might be like Mickey Mouse.
At least 4. He thinks there's at least 4.
I think there's at least 4. I think there's 3 fingers plus the thumb. But it's possible he's just Mickey Mouse, because doesn't Mickey Mouse only have 3 fingers?
Right. He only has it. But now, again, Connected Dots pointed out that, I was saying you don't need the pinky because no one drinks their tea with the pinky anyways, right? It's supposed to be raised. So you only need 4. However, if you want to palm a basketball, you need the pinky. So it's very important for that. So not only will Optimus suck at soccer, but will suck at basketball. Probably the spiral, if you want to do a spiral pass. Isn't the pinky kind of important?
Well, Mark also asked if it could make a pizza, and I'm not sure about that, because the fingers, if you look at the fingers, we think that there's only 2 joints in the fingers as opposed to 3. So like a normal human finger, you have this joint here, which can do this.
This long joint here is called the proximal, and this is longer than it is on the human.
Right.
Then you have out at the very end what's called the distal, and then this one in the middle. I always forget the name of that one, but it's called the middle. Medial? It's the middle bone, right? So
anyway.
Proximal,
but it's
the middle,
fused.
and the
it's
distal.
Basically fused.
Right. So basically, the middle and the distal are fused and already pre-curved, and then this is a little bit longer than normal, and so you just have those 2 degrees of freedom there. And the same thing with the thumb. What's weird with the thumb, when I look at my thumb, it kind of points down as far as the arch that's in there. and the arch on this one goes the opposite way. And again, it's kind of pre-built in what that arch is. And I don't know if it's really rigid or if they made it out of some sort of compliant material so that maybe there's a little bit of flexion going on there.
Right.
And then we have no idea what's there for sensors, but I assume these black areas here are some sort of tactile sensing.
Right.
And it was pointed out by, and again, I want to give credit where credit is due, is once I get down here, we were talking about the fingers a little bit. Oh, let's go run back up here. Copulize thinks he saw nails. And when he said nails, I was like thinking of like carpenter nails, So, there's nails on there. Oh, really? Oh, yeah, your fingernails. So there might be something in there for being able to do the grip.
Right. Oh gosh, Tronicum says maybe the fingers can spin around and rotate. Ooh, there's no. So the problem is the control mechanisms for it. It's just like the human hand. If you look at the human hand, we have no muscles, no nothing in here. It's all here.
Right.
So the deal is to make this as thin as possible so it's flexible.
And I think you're seeing basically the same degrees of freedom. So we can go almost plus or minus 180 with the forearm, and it definitely looks like it can do that. The based on that mechanism that's there, we have about the same for this pitching and a little bit with a yaw. And it's the kind of thing is if you take your normal hand and as you pitch down, if you try yawing, you really can't yaw anymore. The result is you end up moving your forearm. So most of it happens when you're flat, and you'll see the same thing happens to that mechanism, is that as you get the pitch in there and try doing a little bit with them, the mechanism starts to self-collide and just won't work anymore.
Right.
So in many ways, it is just as limited as the human hand. And that's the whole point, because this slide is very key. World built by humans for humans. It's supposed to operate in that. We're not trying to create a new environment that only Optimus operates in. Optimus must operate in the human world. So you're not going to give it capabilities that humans don't really have. There is no need for that.
Right.
And the question is, you may remove capabilities.
A lot of what people say about this is, why would you design it this way? Because you could make it more optimal, doing something optimal. But I think the idea is, the first principle here is it has to behave. It has to interoperate with human beings in a human designed environment.
Right. Now, in my little website, in my little, my little YouTube channel, I posted this just to sort of show, what is it that Optimus could do? Now, this is a typical human operation. If you look at what's going on in the back there with the robots are doing operations that humans can do. They can do welding, they can do assembly and everything else. The problem is that end of arm tooling, only those robots can do that. You cannot drop a human suddenly in there and say, do the welding task right now, because they completely designed it for industrial robots, not for humans. And vice versa. You cannot take a human weld gun and put it in there and expect one of those orange robots to do it. You can't. The idea of Optimus is yet you are able to do the same task that a human can do.
Exactly.
And you want it that way because the idea of Optimus is not to necessarily replace the workers, but to supplement them and to fill in the gaps when needed. Because there are staffing shortages all the time. Every day, some people may not show up to work for a variety of reasons. And that you need someone to be able to go in and do that particular task. And a lot of tasks are simple, repetitive, boring.
Right.
And you see, this is very simple. The whole idea is that the fixtures are going to be there. It's not highly detailed on what's going on, but the idea of the fixtures that you basically just drop it in. Like this poke-yoke kind of thing. There's like, you almost can't screw it up. You just drop it in and the fixturing will locate it accurately for you. So you just sort of pick them up, bring them over roughly, drop them in, they will slide into their appropriate location, and then everything else takes over.
Right.
So it's a very, very simple operation for Optimus to do at the beginning.
Exactly. So, and I think that's important for people to realize too. Number one, it has to interoperate with humans in a human-designed environment. And number two, this is Optimus version 1.0. Like, yeah, eventually in 2040 or something, we might have one with incredibly dexterous, fully formed 8-finger hands like an octopus or something. Who knows? But this is not for version 1. Version 1 is the simple robot.
And the other thing to remember is the idea is that Tesla wants to be able to get return on investment right away. And there's two ways of doing it. They can start selling them to lots of people and make money that way, or they actually can put it in a production environment and starts lowering the cost of manufacturing.
Right.
So, you know, and another example is very similar. I mean, the first one I called Optimus feeding the robots at the zoo, because that's what it looked like. In this case, you know, the question is, oh, what about if the parts are really heavy, bulky, and difficult to move around? Well, humans have the same problem. Is they're not allowed to really lift anything maybe over 40 or 50 pounds, probably less than that. And if they are, they need to use a lift assist.
Right.
Because if you're doing that for 8 hours, there's no way you can lift up a part like that and continue to do this. So these lift assists are designed. It's a very simple tool. Just go ahead and pick it up and move it on over. Yeah. Optimus could do that very easily. Does not have to be really fast. The tack times are already set at being around a minute anyway.
Right. Oh, we got a comment from Teslabot. That's cool. Dusty said, all it has to be is better than a human in a spacesuit in order to go to Mars, which is also very true. If you look at this compared to a person, even with gloves on, I mean, what if you were working around a furnace or something and had to be wearing very thick gloves? That makes your dexterity go way down. So Optimus is going to have an advantage with that too.
Right. So, well, the other thing to remember is that all these applications here in the plant, when someone picking up sheet metal, they are wearing gloves.
Right.
They have to.
Because, yes, exactly. Because
you need the personal protective equipment, and one of them is that they're going to be wearing some sort of gloves to protect their hands from getting cut on that sheet metal.
Right.
No doubt about it. So already your dexterity has gone down a little bit.
Right. So all of these things are really important. Do you think, would it be a good idea to turn it loose and let some people ask some questions?
Yeah. Go ahead. I think I'm pretty much done with my slides.
There's been a good long running commentary stream, so I love it.
Yeah.
Somebody said Teslabot only needs one finger, the middle one. So it's Elon's little thank you to everybody else, I guess. So we can just leave that picture up and people can ask questions about that. Does the Teslabot qualify for UAW benefits? Jeez, we're gonna have robots uniting into a union. So let's see. Human hands and gloves have a lot less dexterity, exactly. So and again, you know, as we said at the beginning of this, if you missed it, we are speculating on a picture. So there's a lot of room for error here.
And we're really good at that. We're really good at speculating on one picture.
But one very good possibility is this is going to be covered with some sort of plastic, rubber, something that will have. Because I noticed a lot of people saying, like, how would this thing how would it pick up something like this? Because it doesn't have the grip, but all you have to do is put some, coating on the outside of this. And it looks like the thumb potentially has something like that. There's kind of a black area there that looks like it might be sort of a grippy.
And the question is that a sensor feedback? Is that some non-slip surface? Right. And again, whether those are fingernails down there or thumbnails.
Right. I like Joy Mutatil, I guess. Could it be pressure sensitive pads on the fingertips? I think absolutely we'll have to have that.
Yeah,
I
there
don't.
would be
It's
some
going to
sort
have
of
to
force
have that.
feedback.
Yeah, it's going to need to know because otherwise it's going to squeeze things too
Yeah,
hard
the thing is,
or
there,
too
there can
soft.
be so many ways to be able to sense that. You may either be sensing it there, or you may be sensing the resistance that's happening on the joints and the
Oh,
pulling of the
true,
tendons.
true, 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 true.
So sometimes that's where you're getting the feedback. That's all you really care about
Right,
is how much tension you have to put in there. Clearly, all this has to be covered because
right.
all this will just snag on things. There's a reason you do not wear a tie on the shop floor
Yes.
because you
That
don't want anything to get caught in anything.
right.
And
That was
this here
that
is
was
just
that was
asking you to
day
get caught
one
in
in
things.
auto mechanics in 8th grade.
Yeah.
The guy, because we all wore ties because that was the school I went to, and he said, "Take off your ties." So,
Yeah.
he's like,
Yeah.
"Do not get that caught in the motor. You'll regret that for the
You
rest of
will
your very
regret
short
that.
life."
Yep.
So,
And this is just asking to be good. That's why I wonder, it's like, why is that thing there? And is that just to
right.
throw us off?
Man, I don't think so. Again, I feel like there's
This
got
is
to be
so big
mechanisms that
here.
control the fingers, and I don't know. We'll find out. It's a very interesting question, that's for sure. A poor cube head. So actually, yeah, 3Headtronicum said, could these things be designed to build themselves? And that's the real question. If we can get a robot that can build a robot, then we've got self-replicating
Well,
robots.
we already do. If you go to the FANUC factory
Right.
over in Japan, they've been doing that for over 30 years, where
Wow.
they've been using their own industrial robots to build their robots.
Right.
Quite a lot of it. And the question is the return on investment on that. A lot of people think it's more for show than anything else. There's a lot of aspects that maybe it'd be easier to have been done manually, but a lot of the steps are there to be able to build. And I think there probably still are some manual steps that they haven't done fully with the robots, but there's a very interesting factory tour you can have where you can see that.
Right.
And certainly I don't see why not. And again, I will double down again. The prototype will be harder than the manufacturing.
That's interesting. So you really do feel like this is backwards from the normal.
This is nowhere near as complicated as a car once you get it figured out.
Yeah,
It's a software problem, and it's a problem with the hands and the sensors. But once you kind of figured that thing out, I'm sure you can start building these things a lot faster. I mean, I don't see any gigapresses being needed for this.
Right. No, or I mean, if they are, they're tiny little, like almost like Hot Wheels sized gigapress. Not,
Yeah, I mean, do you see what
they're
parts
mega
in
presses.
here do you
They're only
see that
mega
would be
presses.
difficult to source? I mean, most of the components might just be off the shelf kind of components, are very easily sourced. And probably the only thing might be, I mean, they're using the chip that they've already designed anyway, so there's nothing else to do there.
Right.
I really don't see, unless they have some really weird exotic material.
Right.
Once you get a pretty good working prototype, you can probably start cranking them out pretty fast and fairly cheap. I mean, we've heard estimates out there when things, well, maybe $10,000.
Yeah. Well, I mean, that's some people's estimates. We'll see what that is.
Yeah.
I don't think Tesla's releasing it anytime soon.
Oh yeah, they're not going to be releasing it, but
Yeah,
the
Elon's
cost of
very coy
manufacture
about
might
that.
be in that order, or at least maybe not the full manufacturing. Maybe that's the cost of materials, and then to put it together is a
Right.
little bit more. But
Right.
still, we're not talking about $1 million a copy. We're talking about something 1 or 2 orders of magnitude
Oh, interesting. So there's a conversation going on in the comments about how it'll be constructed. CNCs, I think 3D printed joints or 3D printed parts would be a reasonable thing.
There'll probably be a lot, yeah.
Especially for the early stages. Like once they want to scale this out and build 100,000 of them, they'll probably build some sort of casting machines. But
Oh yeah,
early
if
stages-
you look at the giant AI video,
Yeah.
all that was a lot of that was just 3D printed.
Right. That's a really big advantage of that now. So here's the hardest thing, just the AI in the Teslabot. Well, I mean, the AI, if you include also the control systems that allow it to balance and not fall over and crash into things. And so I think so. I mean,
most of it's software.
yeah.
It really is. I think it's all in the software. You know, how much you say it's AI and how much is things like the overall control systems. But a lot of the control system stuff has been solved.
Right. But
as,
what did I just see? I just saw a Huawei ad for their robot that they just put out, and I wish I had the video of it right now because I'd bring it up. It's pathetic. The thing it's really creepy. It's got these gigantic hips that stick out, and it looks really creepy, and then it moves and it falls over, and it keeps just crashing and falling over. So I wasn't exactly sure what they were trying to say was like how bad their robot was, but
I was,
solved or not, it's not a completely solved problem.
I can already see Sandy Monroe's take on it. It's crap.
There you go. He'll say,
Almost got the spit take there, John. I tried.
"Oh, yeah, Jomi Mutatil, I guess. I wonder if hardware 4 will be in Teslabot on AI Day 2. Interesting. I would definitely think at least hardware 4 is going to be in Teslabot before it's released. I would imagine it will be in Teslabot on, I mean, whatever prototypes they have, because why would they build it with the old hardware? I
Yeah.
would think they'd want to have it with the newest hardware in it. So, Geo30 Geo5 says, I think this is a real photo. Look at the main hand body parts. The one on the left has rounded edges and some details. Yeah. So, oh, interesting. He thinks that the two hands are actually different, that they're different, like iterations of the same thing. So that's fascinating.
It's
The
it's
one
maybe,
part,
yeah. I think that the big question was whether
right,
this was a photo of the real thing or if it's a
right.
render.
Yeah,
A
exactly.
rendering from some CAD model. And the problem with renderings is they can look very lifelike and very realistic.
Right.
The focusing here is very strange. We've got some sharp focus in a few areas and everything else is kind of blurry. I
Right.
don't know if that tells you if it was done by a camera or if it's actually done in
I,
some rendering package. But
well,
this
no,
over here, and
a
I'm
rendering package, believe me, because that's what I work in. It would be
right.
way sharper. So
Yeah,
they're intentionally making it a little fuzzy.
yeah. And look at this thing here is that this looks like a piece of sheet metal that's bent around to me. And it's like it's
Right.
open and exposed. That's what my eye is saying, but my brain is saying that can't be right. It somehow should be closed and solid, but it just
Right.
has a weird vibe or feeling to it that you just can't figure out. And again, that's why I wonder if things were redacted or if this is a
Right.
really good graphic someone put together.
Well, it's also possible that that's just uh, it's kind of a box, like that there's actual stuff inside there. But,
Mhm.
but again, from this angle, it's just so difficult to tell what's
It's
going
it's
on with
very
that.
hard. It's
Yeah,
very hard to tell. Yeah. So
right.
my first impression was, oh yeah, it had to be Dolly because just nothing made sense. And
Right.
and we know Dolly is really bad at counting limbs. It adds
Exactly.
extra limbs or takes them away.
I
So it's
actually
like that's
asked
why the missing fingers.
I asked Dolly to make the figure, the heart figure with the robot, and it did, but it was way more traditional looking than this.
Yeah.
So so Dolly was not the one that was used for this, at least not directly. So um, let's see, what do we have? Will Tesla bots eventually dominate YouTube channels? That's Steve Rosen. I hope not. Or actually, if I own one, then sure, it can like take over for me. So that'd be awesome. Tronicum says being able to simulate this well helps to speed up design, and I think that's
Yeah.
exactly what you were saying, Scott. That the software is the hard part. If we can simulate this thing a billion times and then put it in the real world and continue to train it, that's the hardest part. That the actual pieces of the Tesla bot are not as weird or science fictiony or anything like that as the
Right.
software that's
Right.
necessary. So yeah,
And it sort of
yeah,
depends upon how well you can model that synthetic
right,
world. Certainly we know, Alpha Zero was playing itself in chess, and same with AlphaGo, and almost learned it because
right,
that environment, there wasn't much to it. It was just the game, the rules of the game. That's all you had to do. Then you
right,
had the hide and seek game that 2-minute videos or 2-minute papers showed,
right,
and there was some physics in there, but they figured out how to hack the physics.
right, exactly.
And but it's very simplistic, but the physics of walking around and interacting in the world is very, very complex. So it's hard to tell
Right.
how far you'd be able to do it without just having it, turning it loose in the real world and then seeing
Oop, I think you just cut out for a second. Sorry.
falling down in that video.
Right.
And
You cut out for just 1 second. You repeat what you just said? Sorry.
okay, yeah. Was the Huawei video was
Right.
showing
Right.
the robot falling down again and again. I mean, that was the whole idea. Probably was like, oh, it falls down, it gets up, it falls down, it
Right.
gets up, and
Right.
eventually it figures out how to walk. And
Yeah.
that might be what they're actually trying to show is like we don't. It's built to fall down and to get up again, and to
Right.
learn from its environment and its mistakes, which is exactly what we do. The
Yeah.
question is, do you want to wait for 10 years for it to get to there, or is it going to learn much faster than a normal human?
Right. Right. So we've got there's a discussion going on about where the batteries are going to go because some people think that those little things are batteries on the side. I kind of don't believe that because, like you said, with the watch,
There-
I think
There's so many places you can
else.
put the batteries. Why put
Right.
it in the worst place?
Right. But I mean, the question of where the batteries are going to go is a big deal because it is going to need very large batteries. So,
Yes.
and again, if you look at like Boston Dynamics, theirs just sits in the back like a backpack. But I mean,
Okay. So
it looked like they
here
were
we
going to
go,
make it in the
John.
middle. So yes.
All right. So this is another test. So for those of you who don't know, my only internet connection is via Starlink. And so their app, honestly tells, you can see there's a little dip there. That's where I just cut out. But the rest of the time, it's pretty good and it's pretty smooth. So you occasionally get that. It's not a big deal. The only time I lose a lot of it is when there's a super heavy downpour and I'm hearing some lightning in the area, but hopefully it's not going to hit us.
Okay.
But otherwise, it's pretty good.
Wow, cool. Let me let me see if I can do this. Sorry, Dusty.
At 5:28, there was 4-second outage. That's it in the last 12 hours.
Wow, that's impressive. And that was interesting because we definitely caught the 4-second outage. So I'm trying to get, Dusty posted a picture of this. Well, crap. It's not going to show up, but he cut the background out. So it's kind of interesting looking, but I can't open it for whatever.
You want to take over?
I would, except it's not opening, so don't worry about it. But it is... I'm looking at it right now. I'm trying to determine if there's any reasonable... It doesn't provide that much useful information. It does show how big the wrists are, though. When you cut out the background, the fact that pack is on there makes them really, really hefty. So it's interesting. Let me see if I can go ahead and if you stop sharing.
See if I can get both of these kind of going at the same time here. Oh, okay.
If you stop sharing, I'll try to share. So
all right, I'll stop sharing.
We should probably be reasonable. It's been an hour, so let's maybe say like 5 to 10 more minutes, answer some questions. And so let me see if I can share this. No, not desktop. This one. Okay.
And my new mechanism, I will be putting together and getting another Google Docs for that one. Cool. Once I get it actually solved, fully solved.
So can you see that or not? It doesn't look like it's actually
I see
sharing.
it.
Whoops.
I'm seeing something.
Oh, okay.
Whether anyone else is, I don't know, but I do see something.
I feel like somehow I've managed to mess it up. I don't know exactly how. So I don't know if everybody can see that or not, because what it shows recording is nothing. So that's unfortunate. But oh well, I'll stop that. So yeah, that's too bad. So sorry. There we go. So power chain, yeah, I don't know. Anyway, well, I'll put a picture of it. I'll link to it someplace. It's somewhat revealing. I don't know how much it helps. It mostly just shows how big the wrists are there. So it's interesting. Okay, so questions. Let's catch some more questions here before the end. The batteries could be structural. Yes, Mars Embassy says batteries could be structural. I have been a proponent of that, saying that they could be, inserted. I think it was actually Dusty that originally suggested that. So I think that might be a reasonable possibility.
Right, but why not put it back here where you get all the room? You don't want to have it down here.
Yeah. So let's see, power charge via QI coiled carpets. I'm not exactly sure what that is, so that'd be pretty cool though. Let's see, what else do we have? The wrist packs are lasers for cutting things. That's all we need. Yeah. It's like wrist-mounted lasers. It's like
yeah.
It's more This is the problem with us human beings. All we want to do is design a Terminator.
If it is, it may not be for cutting, but it could be for some sort of calibration or tracking. But I don't think that's the point. I think the idea is you want Optimus to do with the eyes. I don't think they want to actually.
That would be interesting though if they had cameras down here though. But I don't think you'd need that big of a mount for a camera. It would just be tiny little things.
Yeah, so. And I don't think you necessarily need to have it there. And if you did, I think you'd want to have it coming from the eyes anyways, and the glowing red.
Right. Gotcha. Yeah. I hope the sound and video got back in sync again. I think when I tried to share the screen, it really messed things up. So sorry about that.
So, yeah, I mean, the other weird possibility with that mechanism is whether it's just like a solenoid that makes those things pop in and out. But I don't think so because you have no control. Just like on or off.
Yeah, that's true. So wireless charging, Tronicum suggests that. I think we've talked about that he could either be directly plugged into things via a cable, which hopefully you would design it so that it could actually pick it up and plug it in itself. You'd want it to be able to plug in itself. But
we've already seen the prototype with Tom Brady, right? I think it was like right here.
There you go. But then I think also ultimately wireless charging would be really valuable. As it's standing working, it would be being charged.
Right on the feet. Why not?
Yeah,
that would be one way of doing it.
So, Geo30 Geo5 says, look at the edge leading from the wrist to the forefinger. The left hand has a curved edge and the right hand is a blunt angle. So if you bring that back up again, hopefully it'll share properly. And Borg style.
Share screen, and here we go. Okay.
Hopefully, yeah.
So we want to look at the left hand.
So
okay,
yeah, so let me go through
this.
At the edge leading from the wrist to the forefinger. Okay. So the left hand has a curved edge. Oh yeah, it does. It might be just a very slightly different angle, but if you look at that, there's that reflection there. It's slightly curved.
Yep.
And the right, it's hard to see, but it's really flat looking.
Yeah.
So it is possible it's just a slightly different curvature, like angle on the hand, but it is possible that the two hands are slightly different iterations of the Teslabot hand. So interesting. That's a good point that you just pointed out.
Yeah, that does look very flat here, and that does look a bit curving. Again, it's just a question of the lighting model that they were using and the perspective, and that we're not straight on, but we're turned a little bit like this.
Right. Michael Mooney says, or Muni, sorry, they could just have two metal pads on the floor to charge while standing.
Yeah.
Yes, but you would have to be a little bit careful, that the voltage wasn't so high that you'd shock a person if they walked by, but I'm sure that's doable. So basically like your Roomba, when it drives up on the little thing, it's got the two contacts that it.
Oh yeah, they could do that. Yeah.
Yeah. Okay.
So not necessarily wireless charging, but as they're standing on something.
Right.
You don't want to have a third rail.
Right. So Dusty says, what kind of hinge is in the thumb? It looks like a door hinge to me too. That's what Dusty says.
This is weird. I'm looking at the perspective of this. I'm saying, imagine this is a piece of sheet metal.
Right.
And there's a slot in here that it can normally slide back and forth. Now you took that piece of sheet metal and you bent it around.
Right.
And you have a slot here and there, or a tab in there, and it just runs along that little track. As it goes around the track, you get that kind of motion from your thumb.
Right. Yeah.
I'm not saying that's what it is, but looking at it, it's like, is it? I have no idea.
But
so
again,
it has, yeah.
This reminds me again of, as an animator, I get to design characters that can just magically move, but that's a really cool motion, but how the hell do you drive it? Like, what are the things
that's the first thing I was thinking. It's like, cool, but
yeah, exactly.
How does it
do
move?
You make that work? Yeah.
Now, it does look like there's a reason for the rest of this mechanism in here.
Right.
For supporting some stuff and probably maybe having something run through here. There could potentially be another little pulley mechanism down there to have this thing ride through. Who knows? And they might be coming up with some really clever ways to be able to move that back and forth just based on the tension that's going through the thumb. Who knows?
Exactly. But again, this is why I'm going to reiterate. I'm going out on a limb and saying I think that those packs on the back of the arms are for control of the fingers. I think that it's some sort of cabling system, and that's how they're driving.
I'm just wondering how they're routing it through here.
I don't know. It's really hard to see.
I don't know how they if there's some sort of cabling, somehow I think they're going to pack it into the palm itself.
Oh, okay. So you think the drive mechanism too? That's interesting.
Maybe.
So
maybe, or again, are they able to take what looks like these little bands that are going through here? I don't know if they're able to go through here, like you say, do it. But if that was a drive mechanism, I think you'd move it back somewhere. I think you have enough space somewhere back here.
Right.
Could be completely wrong, but I would think it would be there not to be the bullet.
So Jay Collins said, would the Teslabot have more than two cameras, do you think? I believe I brought this in this time for a reason. I forgot this last time. There it is.
Autopilot cameras. Yes, it has more than one.
I think it's going to have the same number as autopilot would be my guess. That it'll have like 8. So
it has the eyes in the back of your head like your mother. Like
I know. That's the terrifying thing about this Teslabot is it's going to know what's going on behind it. You can't tease it.
Wait. Look, I wonder what these things here are.
That's an interesting
question. Those look like the cam. See, the autopilot cameras is this a camera there, here, and here?
Maybe.
Did we miss that?
It could definitely be. So maybe let's see how there's 1, 2, 3, 4, 5, 6, 7. Yep. If you count that up, there's 4 in the head and then 4 in the body. So it could.
Boy, we keep on seeing more and more things, don't we?
Yeah. We need to pay more attention to these pictures. So
the way it's walking down here looks at some similar things, mechanisms. There's some sort of ligaments and tie rods in here to be able to move things around. Yeah, that's probably.
I lost you again for just a second. I wonder if Starlink cut out for a couple seconds.
Oh, I can tell you for sure whether it was on your end.
Hand hinge is USB or other data point. Interesting. That's an interesting question.
Wasn't me. It was not me.
Interesting, because it could have been my problem then.
See, the
So
dip
Todd
that's over
Murray-
here is about to go up. That was the original dip. It's going away.
Gotcha. Todd Murray said, "Why is the shadow on the left arm yellow tan under the wrist box?" We don't know. It's obviously reflecting something, but we don't know what that thing is. So in the picture, yeah, that there's
Let me
lots
get
of
back all the
weird
way to
reflections.
the original. Yeah, these here, we're trying to figure out why is it
Right.
tan or gold over here and not over here.
Right. And we just don't know.
Well, C-3PO was gold,
Mm.
but he did have
So-
some silver components in one of the movies, remember?
Right. So here we go. James JOWUA says that the hands have to be dummy hands because he can't see the actuators. What do you guys think about that? So,
okay.
Mark Plott has definitely a good point, which he says the charge port should be in the butt. Because, I mean, open butthole. It's like, it's got to happen, right?
Okay.
Or go
okay.
sit on it, Optimus.
Yeah, this is the thing, is the question. So they're dummy hands. So James
That's
thinks
what
these
he's
are-
saying. So he's saying that they're not actual real hands. But again,
not
it
the
could
real
be
deal.
internal. I mean, he could be right.
Okay.
It's-
Now, since James is online, he is the one that came up with the $10,000.
No. This is somebody
remember?
claiming that James JOWUA said this.
Claiming
I,
that James
I haven't
JOWUA.
seen this
Okay,
personally. Yeah.
Yes,
But anyway,
okay.
sorry, who was that? That was Geo30, Geo5 said that. So there you go.
Okay.
Yeah, we need to get James online right now and have him like respond to this. So
Yeah, I can talk a little bit about the kinematics and stuff like that, but he
Right.
clearly can talk about the AI
right.
and probably a lot of
again,
the hardware that's going on
There's
there.
an awful lot that we don't know. I mean, I'm intrigued by the idea of memory metal that Mars Embassy brought up first. I think that's a really interesting idea, but I don't know if you can.
I don't know how
force
exotic they
something-
want to be right away. I
Right.
think you want to kind of stay traditional on your prototype,
Right.
and they
Right.
know how to make certain kind of drives and everything else.
Right.
And if you do too much right away, I mean, remember what's that, like the fifth one, optimize?
Yeah,
And
exactly.
it seems like using something exotic like
can
that
you?
is
I'm
optimizing.
getting a request from Robert Bergman to zoom in on the hand. Just pick one side and like zoom in, because since you're the one who's in charge of that.
Okay. Yeah. Let's see if I can even zoom in on this. Okay, you're asking
Well,
me
you
to
have
do
the
something on
zoom
the
in
fly here.
where you had the rotation.
Oh, okay. I think
Yeah.
at some point I have one that is like this.
Yeah, like that. There we go. So I mean, that's a pretty that's it doesn't show everything, but it does look at the thumb. That's really interesting when you zoom in that far. It looks more like a barrel. So
It
something
looks like a
could
piece
have-
of sheet metal hanging out to me. It just
Right.
doesn't belong there.
It's very
It's some
weird.
really weird artifacts.
And the angles are so harsh there. They're like super 90 degrees. Very weird. So
And again, I don't know why you have this sleeve inside of that sleeve.
right.
That would usually indicate some sort of telescoping mechanism, which
Yeah.
would tell you that maybe it is a servo drive. So my idea of everything being way back at the other end is completely off.
Well, but it still could be. It just could be a sleeve that's inside of another sleeve. So, for protection.
That's possible that they want to do it to kind of protect the movement of that from
Right.
something
Because
else.
you have to think like as it gets closer to that big part, it could get tangled up in there if it was just.
And it
one
could be
piece.
that it's not really riding inside of this. Is almost like a conduit that's protecting it because
Yes.
it has to be able to wiggle around in there.
Exactly.
And that could be the reason, is that it's wiggling around in there and you're just making sure it doesn't bind or get caught up in anything else. You're absolutely right. So
Here's
it could
a
be
good
that's not
question.
concentric with this one at all.
Here's a good question. Jay Collins says, "What do you think the bot will be able to do on AI Day?" You go first.
An AI day, boy.
2 months, less than 2 months.
Well, probably. That's sort of funny. I haven't really given that deep thought. I know a lot of other people have, and the things they think it's going to do, I was like, no, I think it's not going to be quite that advanced. I'm more in the camp of sort of what James JOWUA said, that it's going to do something fairly simple, and the rest of us are just going to be blown away from
Right.
it. Those that are really involved in it, and everyone else is going to be yawn. That's all it can do, really?
Right.
And just if it can walk up on the stage go upstairs, walk around without falling around, do a couple of things, maybe pick
shake
something
Elon
up,
Musk's hand or something.
maybe shake his
Yeah.
hand, maybe do a simple
Maybe
task,
like wave. So
probably be asked, go pick
play
up that
chess.
thing, bring it on over here. They might even show some very simple manufacturing tasks that could be done in the
Right.
factory, since that's what it's really designed for.
Right.
This idea that it's going to drive up in the roadster and get out and deliver Elon a pizza,
Right.
I don't think so.
Man,
think
if
anything
it
like
can
that's
get out
gonna
of a
happen.
roadster, it's better off than I am.
Yeah,
Those things
yeah.
are small. So
It'll do something, but again,
right.
there's going to be limited mobility in it, so don't expect it to do the dancing or anything like that.
Right.
So I've seen a lot of
Oh,
animations of dancing where it's doing this, bobbing its head. Like, nope, it
right.
doesn't have that great freedom.
So Todd Murray has the perfect thing. What it needs to do is throw a steel ball at a Cybertruck.
Yeah,
If it can do that, we're all set. Everyone will go crazy. So, Tronicum says dancing. I really don't know about dancing. I think that I don't think it's going to be designed to be very.
you can't if you can only walk at 5 miles per hour.
Yeah.
What kind of dancing can you do? Not really
Well,
wild dancing, not break
it
dancing
could
or anything
do
like
like
that.
Elon dancing.
Yeah, yeah, that's basically
So
what I
there
do.
you go.
It's
Break. Mark Plot says break dance. I hopefully not actually explode. So
yeah.
it'll be literal break dancing. Get beer from the fridge. That would be fantastic. I would love that, Jomi. They might not even show a live demo, just a few video clips of it in the factory. If it can walk, that's a huge success. Absolutely. Lol freak waka. Stab a knife, make a beer, dance, So yes, there's a lot of suggestions. I think the basic idea is don't get this idea in your head that it's going to come out and like start, John Travolta dancing from Saturday Night Live or something. It's going to be, if it can walk around and especially as you said, go up and down stairs, do some basic task without falling over and collapsing. That is massive.
Yeah, just tell it to go get this, get this box, and we're going to move the box to some location, some random location. Then it's very clear it has to identify the box and get it, and it's not something that was structured ahead of time. I kind of like the idea that there may be, I think, some videos showing it, some more advanced applications that you just can't bring a crowd in to see.
Yes.
And who knows, it might even be live.
controlled
It might be they have
circumstances.
cameras out of the factory says, here's what it's doing right now.
Right.
And now we'll introduce it, and then it can kind of come up on stage.
Yeah.
And you'll see it do a few things.
I mean, if it does something as crazy as getting out of a car and delivering a pizza, I would fall over probably. I mean, that would
that would be impressive, especially if it drove it.
Mind-blowing stuff, yeah. So
The question is that when it drives, it doesn't know whether it's in full self-driving or not.
People are starting to say that they need to take off here, so we should
Yep.
probably wrap this up soon.
We can wrap it up for sure.
Let's see. One more good question. Let's see. Walk around carrying a cardboard Elon, wave to the crowd. I do believe waving to the crowd would be a pretty decent, just the fact that it's able to stand up and do this without falling over as it moves its hands would be very nice.
Oh, do the Tonight Show thing.
Oh, yeah. There you go.
Okay,
Clap to the crowd, things like that. Yeah. So, I mean, ultimately what Elon came out for the shareholders meeting and he walked on stage and he waved to everybody and said, what a great crowd. What if the Teslabot was the thing that came out instead of him right at the beginning? I mean, that would be massively impressive. It would also be, I would be terrified if I was Tesla because, of course, the thing could stumble on the stairs and end up on the ground flailing. So it would be a little bit of a risky thing. But, yeah.
Yeah.
Spin a basketball on one finger. Jeez.
Yeah, I know. I've heard the one thing about the idea that the Tesla bot is going to throw Elon, a pass or something like that.
Right.
And the one thing they say about, if you're an actor performing, you never want to perform with animals because you never know what they're going to do. In this case, the animal is Elon.
Exactly.
And Elon is not exactly the most athletic. So I'm afraid that, Tesla bot will throw the pass, Elon will drop it. And there'll just be all kinds of bad press about that. So no, they're not going to have anything athletic like that.
Right. We got Geo30 says Tesla's not afraid of live demos, as we clearly found out from the Cybertruck thing. So David Copperfield, I like that. If it comes out of a car, welcome to our robot overlords, indeed. Terminator theme playing. I love all these ideas. These are great. So if I have to throw out one idea, it would be, I know this sounds really lame, but walking up the stairs. I think if it can walk on an unlevel surface, I would be completely blown away. And everybody else in the mainstream media would say, like, what the hell?
Well,
Say, like,
well,
my
maybe
toddler
they
does
even have
that.
different surfaces. Maybe they'll have
Yeah,
it walk across different surfaces, a
right,
sandy
right.
surface, a slippery surface, a rough surface,
Exactly.
just to show that it can go from one to the other
Right.
without falling down.
And then basic things like picking up stuff and putting it down. These were all, especially if it does it faster than like what tenth of what humans do. Because a lot of times robots these days are kind of stuck. They like, reach, they grab something, very slowly move it,
Right.
go put it down. It's like if it can do it more of a normal human speed, that would be pretty amazing.
Yeah, that would, maybe they're going to have some kind of sort of like a John Henry kind of
Yeah.
scenario where the robot's going to come in. And like you say, maybe there is some very simple task that it can do and it's able to do it pretty quickly. And then you have a person doing it, and then you see they're kind of keeping up, but then the operator's getting tired because the robot's just going back and forth. So it might be like a tortoise and hare kind of thing.
Let's not kill the poor
Some
guy,
simple
though.
competition.
So there we go. So yeah, I think I like the idea of playing Terminator themed music when he comes out for sure. So,
no, I think
Elon is
it'd
trying
be
to
the wrong vibe.
Yeah,
it'd be the wrong vibe.
But I have to say this all stainless steel Teslabot here, or aluminum, whatever, is a little bit terrifying. It's starting to look like the Terminator exoskeleton. So he's just easing us into this right now. Pick up and use a tool. That's what John D says. I think that's actually brilliant.
Well, that's what it has to do.
Yeah, but I mean, if it could do it during AI day, if it could pick up
sure.
a power drill.
You just put a couple of tools, put a couple of Black & Deckers around there, and just have it go ahead and say, all right, pick this up and go ahead and drill a hole.
Right.
And then maybe pick up a screw gun or something like that and put the screw in.
That would be
and just using human tools. Yeah. And just making sure that, maybe you bring someone from the audience to say, okay, just place these randomly somewhere on the table. So it's not a Tesla employee that's got it in the right place. Just put it here and there, and the Tesla bot will go over and figure out, oh, there's that tool. I need to pick it up.
Right.
I have enough fingers to do it. Is it 3 or 4? We don't know. And then it does some sort of operation. Yeah.
Someone else, I lost it back up here, but somebody asked about speech synthesis. But I actually think speech synthesis is relatively straightforward. I mean, that's all stuff that Alexa and Siri and all of those things can do already. So I'm not too worried about that. And plus the fact Tesla's cars already, you can talk to them and give them basic instructions. So yeah, but I mean, if you could say something like, Optimus, pick up the drill and drill a hole in this board. Like if it can understand that and execute that, that would be huge.
If it could change a drill bit, that would be impressive.
Ooh, wow. That's actually not that easy to do. So yeah.
Yeah, and I mean, that's something we do at home. In the factory, you don't do, I mean, everything's already kind of set up. And if you do a change, it's going to be a really quick change. But if it can go in and find the 1/4-inch drill bit and take it out, put it in, that would be impressive.
We've got some really cool things. Have it build crafts in the background during the entire presentation. So it's just sitting back there. That would
sitting there knitting.
Yeah. And then Jomi says, walk up to the keyboard and play the Terminator theme. So again, I think we've established it's unlikely that this is going to be able to play piano particularly well, but especially if it only has 3 fingers.
It can do chopsticks.
It's like ding, 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 ding. So there we go. Make a perfect espresso. There we go. So yeah, fluid human movement. Yeah, that's what Gareth is saying here. I think is really important. It's like the basic, just do something basic, but not look like a robot, look like a person. I mean, it doesn't have to be that impressive. Just that would be massive. So yeah, right. Cook an egg, fold an origami swan. Man, that's a lot of dexterity.
That would be tough. I mean, if it could pick up an egg without breaking it and then break it correctly.
Oh, that's true, because you have to like crack it on the. Yeah, I mean, cooking an egg would be, and then you'd have to pick up the spatula and like flip it.
Because that is the big test, being able to pick up an egg without breaking it.
Right.
And then be able to pick up something that's a little bit heavier. And have the strength for that. That would show a lot of dexterity.
Right. So
that's kind of the Turing test of robotic hands.
Right.
Picking up an egg without breaking it.
Yeah. Milk a cow. Jeez. So I think everybody in the comments, we're having a lot of fun talking about this, but don't get too carried away because it's unlikely to be in demo 1 that it's going to be able to do quite that much stuff. I mean, like you said, cooking an omelet would be a pretty massive undertaking. That is a basic robotic Turing test. So riding a unicycle while juggling, why not?
Yeah, yeah. Oh,
Jeez.
shooting baskets, right?
Right.
That was in, which movie was that in?
Oh gosh.
The sci-fi movie that,
Shooting baskets?
yes, yes, yeah, yeah.
No.
There was one of those interstellar kind of movies where it's, generational and you just have the robot that's tending the spacecraft the whole time.
Oh gosh.
I think Jennifer Lawrence was in the film.
Oh, is it called Passengers? I think it is called Passengers.
Something like that.
Yeah, yeah, yeah. But that's a good point. Oh, this is interesting. Leslie Franklin says a Craftsman Factory, which is a tool making company, just opened in Texas. So how about send the Teslabot to the Craftsman Factory and have it grab some tools. So there you go. Glass blowing demo. Jeez. All right, folks, I'm going to call this one. We have been talking for almost 90 minutes, and this has been a blast. But I really enjoy this, and thank you so much, Scott, for being part of this and for creating these little demo things. These
A lot
are
of
great.
fun.
Yeah,
A lot of fun,
I think that we'll have a lot more to talk about as the time gets closer. But the interesting part is going to be 6 or 7 weeks from now, whenever we get to September 30th, to see just how wrong we were in so many areas. So hopefully we'll be right in 1 or 2 areas. So anyway, thank you to everybody who's been watching. Really do appreciate it. And for everybody who comes in after this is over, read the comments as we're going. So, that it's all good stuff. So thank you to everybody and have a lovely evening. We'll talk to you later. Bye-bye.
Yep. Cheers. Bye.